All right, everyone, let's take notes for lesson 7. Lesson 7. Okay, to start us off, we are going to cross out this whole thing, this thing right here. Okay, this just tends to confuse students more, and we don't really need to know these terms. We're going to cross it out. Okay, so feel free to cross it out. Go crazy. All right. Okay, but we do need to know theoretical versus experimental probability today. Okay, so theoretical and experimental probability. So theoretical probability is based on uniform probability. I know we're using a word that we have not defined, but just write it down. Uniform probability. Okay, and this is what should occur when conducting a probability experiment. Okay, you can even cross this part out, I suppose, okay, because we don't really talk about uniform probability. Basically, theoretical probability is, theoretically speaking, okay, theoretically speaking, what should occur. Meaning, if you toss a coin enough times, okay, the time number of heads should be 50%, okay, theoretically speaking. And number of tails should be 50%, theoretically speaking. If you have enough babies, number of boys should be 50%, and you have a number of girls should be 50%, theoretically speaking. Theoretically speaking, again, half of the world population should be men and half of the world population should be women. And this is, again, theoretically speaking, okay, what should occur. Now, in real life, we all know, hopefully we all know that's not how real life works. So experimental probability can be a little bit different. So experimental probability is based on relative frequency. Okay? Meaning if you have only 2 babies, okay, chances of you getting 1 boy, 1 girl is not going to be 50% and 50%. Okay, whereas if you have enough number of babies, eventually it'll be more likely to be 50% and 50%. So this is based on relative frequency. Okay, and this is what actually, okay, not what should, but what actually occurs during an experiment. Okay, you do an actual experiment, and this is what actually happens. Okay, all right, so let's talk about this. The table shows the results of an experiment in which a number cube was rolled. Find the experimental probability of rolling a 6 for this event, then compare the experimental probability with the theoretical probability. Okay, I'm going to actually skip this and go to the theoretical probability part. Okay, theoretical probability starts right here. Let's talk about theoretical probability. Forget this experiment for now, but theoretically speaking, you're rolling a number cube, okay? So theoretical probability rolling a 6 is, how many 6s are there in a number cube? Okay, number cube, it's got 1 through 6, and there's only 1 6. All these numbers are other ones, right? So there's 1 6 out of 6 different numbers, okay? And if you calculate the percent for this one, 1 divided by 6 comes out to, and then multiply this by 100. So we're looking at about 16.6 repeating percent. I'm going to round this about 17%. Okay, so you've got about 17% chance of rolling a 6 on a number cube. Okay, but is that what really happens? We have an experiment that was done right here. Okay, it talks about the number cube numbers 1 through 6 here. And then how many times you got, okay? How many times you got those numbers. And as you can see, these should be equal chance. Chance of you getting 1, 2, 3, 4, 5, or 6 should be equal. But if you look at these numbers, look at it. Oops, let me erase this. your number 4 was chosen 8 times, whereas number 2 was chosen number 3 was chosen only 2 times. So as you can see in a real life experiment, it's not going to be always the same as the theoretical probability. Okay, so let's look at this now. We're talking about rolling 6. 6 was rolled 6 times. Out of total, so total frequency is you do 4 plus 6 plus 2 plus 8 plus 3 plus 6. So if you add up all of them, total frequency, total number of rolls was 29. Okay, so you got 6 over 29. Okay, you simplify that 6 over 29. We're going to be repeating this for a while. Okay, so probability of, experimental probability of rolling a 6 is 6 over 29. Sorry to make you do it over and over. And now we do percent 6 divided by 29. And this comes out to 20.7-ish%, so about 21%. Okay, so actually it occurred 21%. Theoretically, we expected 17%-ish. Okay, so rolling a 6 in a number, okay, hold on. So rolling a 6 in the experiment occurred more often than expected is what we say. More often than expected. Okay, so again, this lesson talks about what's expected. Okay, theoretically speaking, what's expected, but what actually happens in real life. Okay, let's talk about this next one. It says find the experimental probability of rolling a 4 or from the experiment above. Then compare the theoretical probability. Okay, so let's talk about theoretical probability first. Rolling a 4, there's still only 1 4 out of 6 numbers in the number cube. So it's same as theoretical probability of rolling a 6. Okay, this one comes out to about 17%, just like before. Now let's look at the experimental probability. Okay, so for this one, 4 was rolled. Remember that was the highest one? 8 times. Okay, 8 times out of 29. Okay, so if you figure out the percentage for this one, 8 divided by 29, you get 27, almost 28%. I'm going to round this to 28%. Okay, so comparing this, and you would say, compared to the theoretical experiment, it says, you'll say the experiment. Oh, actually, I'm sorry, you guys. I would have to say rolling 4 in the experiment occurred more than expected. Okay, because again, theoretically, our expectation was only 17%. But it actually occurred 28%. So it's more than expected. Okay? All right, so let's go on to the next page. Making predictions. Now we can use a theoretical or experimental probability to predict the future events. Okay, so let's look at this one now. The table shows the results of a survey that asked 200 teens what they would be doing if they were not online, if you're not online on the phone or on the computer. Out of a similar group of 450 teens, predict how many would listen to music. So this is survey of 200 total students, okay? Because it says right, they asked 200 teens, so this is out of 200 teens, okay? Listen to music, okay? How many will listen to music? 52 answered they'll listen to music, okay? So now we're going to do people number who said listen to music will be the favorable outcome. That's 52 out of total. We don't have to add them all up because they already told you it's 200 teens. Okay, we can simplify this, or you know what, let's just use calculator. 52 divided by 200 comes out to 0.26, or this is 26%. Okay. Now we use the percent proportion to find 26% of 450. Because again, the direction says, out of a similar group of 400 teens, predict how many would listen to music. Okay, so now we got to make the prediction. This was only for 200 people. Now we got to make a prediction for 450. So we figure out, we can do part over whole. I want to do, actually, forget the part over whole. I want to figure out 26% of 450. So 0.26 of 450. I think this is so much easier than doing the proportion. So 450 times 0.26, and that comes out to 117 teens who listen to music out of 450 people. Okay? All right, let's try the next one. It says out of 450 teens surveyed, how many would expect to say they will be writing or drawing? Okay, so we're talking about the same survey, and we're talking about writing or drawing. Let's look at this. Writing is right there. Writing or draw is 10 out of 200. Okay, so we've got 10 favorable outcomes out of 200. Okay, so that's 1 out of 20. So 10 divided by 200 comes out to, times 100 is 5%. Okay, so now we have to figure out the 5% of 450. So 5% of 450 would write or draw. Okay, so it's gonna be 0.05 of means times 450, and 450 times 0.05 comes out to about 22.5 teens. Okay, you can't have half a teen. So for this one, I would round it to 23 teens. Okay, all right, so that brings us to the end of the lesson for today.